Hello everyone. In this video, we are going to cover major topics that will give you a solid foundation in Web3 and blockchain technology. First, we will look at the evolution of the internet. Then we will understand what is decentralization and we will explore the fundamentals of blockchain. And lastly, we will look at the major blockchain platforms like Bitcoin, Ethereum, and Arbitrum. All right. So you might have one question that what exactly is the difference between Web 2 and Web 3? As you can see from these visuals, the evolution of Web 3 has been dramatic. But to truly appreciate where we are now, let's start from the beginning. Think about Web 1, the internet of the 90s and early 20s. To give you a relatable example, think of Doordarshan or DD, which is India's public broadcaster. Web 1 was like Doordarshan. It was read only, you could consume content, but you couldn't interact with it. Websites were static pages, you visited, you read, and that was it. There was no commenting, no uploading your own content, no social interaction. It was a one way street of information. Companies and organizations broadcasted information and users simply consumed it. Just like how you couldn't talk back to your TV when watching Doordarshan, you couldn't interact with Web 1 websites. Then came Web 2, and this is the internet you know and use every single day. Web 2 was revolutionary. Suddenly, the internet became interactive. You could upload photos, post status updates, comment on your friends' content, and truly participate. It was no longer just consuming, you could create. Platforms like Instagram, Facebook, Twitter, YouTube, they all emerged during the Web 2 era. The internet becomes social, dynamic, and user driven. This sounds great, right? And in many ways, it is. But there is a catch. We have two major problems. Problem one is you don't have control over your data. Let me ask you something. Think about every photo you have ever uploaded to Instagram, every tweet you have posted, every video you have uploaded to YouTube. Who actually owns that data? You might think that you do, but you don't. The platform does. These companies can change their terms of services whenever they want. They can delete your account, they can use your data to train AI models, they can sell your information to advertisers. And there is nothing you can do about it. You have created all this value, but you don't truly own any of it. You are essentially renting space on someone else's platform, and they can change the rules at any time. Now, let's talk about the second major problem with Web 2. Someone is regulating your currency. Every financial transaction you make online goes through intermediaries like banks, payment processors, credit card companies. And behind all of them are central banks and governments who control the money supply. They can print more money, causing inflation. They can freeze your accounts. They can restrict where you can send money and to whom. They can impose transaction fees. They control the value of your hard earned money. In many countries, people have watched their savings evaporate due to hyperinflation. In others, citizens face restrictions on international transfers. The traditional financial system is centralized, and that centralization creates problems. You don't have true ownership of your money when someone else can control it. So let's compare Web 2 and Web 3 side by side using an example. Let's take Instagram, built on centralized infrastructure, all servers owned by an organization. Whereas in Web 3, we have distributed infrastructure, no single company owns the servers. In Web2, platform owns the user data, whereas in Web3, you own your content and your identity. In Web2, content is distributed using algorithms decided by an organization, whereas in Web3, the content distribution is transparent and you can see how the algorithm works, or even you can choose your own algorithm. In Web2, monetization is controlled by platform, whereas in Web3, the monetization is controlled by the creator. But how do we solve these problems? That's where Bitcoin and Ethereum comes in. You may remember problem 2, where someone is regulating your currency. Well, this is where things get really interesting. In 2008, during the global financial crisis, when banks were failing and governments were printing money, an anonymous person or group using the name Satoshi Nakamoto published a paper and then they released Bitcoin. Bitcoin was the first breakthrough that actually solved this problem. Here is what makes Bitcoin so powerful. First is no central bank can control it. Then no one can print more of it because there will only ever be 21 million Bitcoins and that's hard coded in the system. No one can freeze your Bitcoin. It's yours. No bank can lock your account. No government can seize it without your private keys. And you can send it to anyone, anywhere. All the transactions are secured by cryptography and they are validated by thousands of computers worldwide through a process called mining. The network itself, through a consensus mechanism, maintains everything. It's trustless. You don't need to trust anyone, you just need to trust the math and the code. But here is the thing, Bitcoin only solved the currency problem. It's really good at being digital money. But what about problem one, where someone else controls your data, your digital identity, and your content? Bitcoin can't run complex programs or applications. That's where Ethereum comes in. So, if Bitcoin is digital gold, a store of value, a currency, then Ethereum is a world computer. Launched in 2015 by Vitalik Buterin and a team of developers, Ethereum took blockchain technology to a completely new level. While Bitcoin lets you send value from person A to person B, Ethereum lets you run code and actual computer programs on a decentralized network. These programs are called smart contracts. Every computer connected to the Ethereum is running the same programs simultaneously. There is no single server that can go down, no company can shut it off, and no government that can censor it. It's distributed across thousands of computers worldwide. So in Ethereum, you can build decentralized applications, you can build digital assets that you truly own, like NFTs, you can build financial systems without banks, which is called decentralized finance, and you can build social platforms where users own their data. Ethereum doesn't just solve problem one, it completely reimagines what's possible in the internet. It gives us a programmable ownership and control. Bitcoin gave us digital money, Ethereum gave us a programmable digital economy. It's not just about currency anymore, it's about building an entire decentralized internet where users are in control of their data and identity. Now, let's talk about how blockchain actually works under the hood. At its core, the architecture is very simple. It's like a linked list. Imagine a chain of blocks where each block contains transaction data, a timestamp, a cryptographic hash of the previous block. Each block is linked to the previous one, creating a permanent tamper-proof record. This simple structure is what makes blockchain so powerful. Thousands of computers maintain copies of this chain and verify new blocks through consensus mechanism. This is how we achieve decentralization. No single entity controls the data and everyone can verify its integrity. Let's talk about one of the fundamental differences in how we interact with Web 3 versus Web 2, which is authentication. In Web 2, we use passwords. We create an account with a username and password which is stored on a company's server. If the server is hacked, your password can be stolen. If you forget your password, you need to reset it through email. You are trusting the company to secure your credentials. Whereas in Web3, you use cryptographic signatures. Instead of passwords, you have private key, essentially a very long random number that only you can control. This private key generates a public address which is your identity on the blockchain. When you want to log in or sign a transaction, you create a cryptographic signature using your private key. The system can verify you own that address without you ever revealing your private key. It's mathematically impossible to derive your private key from the signature. This means that no password can be stolen from the database, no company stores your credentials, and you are in control of your identity. Now, let's talk about the developer tools in Web 2 versus Web 3. In Web 2, if we want to develop any backend, we use Node.js, Express, Django, etc. Whereas in Web 3, the backend is written in smart contracts using languages like Solidity, Viper, and Rust. In Web 2, we have databases like MongoDB, PostgreSQL, etc. Whereas in Web 3, the blockchain itself is a database like Ethereum, Polygon, Solana, Arbitrum. In Web 2, we use OAuth or JWT for authentication. Whereas in Web 3, we authenticate using wallets like MetaMask and Wallet Connect. In Web 2, we have cloud services like AWS, Google Cloud, Azure. Whereas in Web 3, we have decentralized storage solutions like IPFS, Filecoin. We use React, Angular, Vue.js, Ruby on Rails like frameworks in Web 2, whereas we use Hardhat and Truffle frameworks in Web 3. So, at the heart of blockchain is cryptography, specifically a process called hashing. Think of a hash as a unique digital fingerprint created from any piece of data, no matter how large or small. When we type hello, it generates a long string of characters. If we change even a one letter, the entire hash changes completely. This makes hashes incredibly reliable for verifying data integrity. Now let's look at how data is structured on a blockchain. Information is grouped into units called blocks. Each block contains several key pieces of information. An index number, which is block number, some descriptive data, and hash of its own contents. But there is one another field which is called nonce. So our blockchain is designed in a way where hash of any data starts with four zeros. Now, if we try to change the data, you can see the hash has changed and it's not starting from four zeros. And because of that, we can see this red block. So now to make it start with four zeros, we can't change the data, we can't change the block number. The only thing we can change is nonce. So let's try to mine it. And as you can see, nonce has changed. So nonce is a unique number and miners mine it, which means that they find the unique number for the given data so that the hash starts from 4 zeros. Now let's look at blockchain. Here you will see one additional field which is previous. This is the secret source that creates the chain. When we add a second block, its previous hash field is automatically filled with the hash of the first block. This creates an unbreakable link. If someone were to try and alter the data in the first block, its hash would change, breaking the link to the second block. This immutability or permanent record keeping is one of the blockchain's most important features. So if I try to mine it, the hash will change and it will start with 4 zeros, and that hash is passed to the next block's previous hash field. So I need to mine this as well. And similarly, we need to mine all the blocks to make our data permanent. But blockchain isn't just one single chain, it's a network. This demo shows multiple peers like peer A, peer B, and peer C, each maintaining their own copy of blockchain. When a new block is added by one peer, it's quickly verified and propagated to all the users. This distributed nature means there is no single point of failure and no single entity controls the data, making the system highly resilient and transparent. So, if we try to change the data in peer A's block 1, you can see peer A's all blocks are changed, but that has no effect on peer B and peer C's system. So, if any attacker tries to change data in one system, even then he would not be able to make that permanent because blockchain is a network of distributed systems. Now, as we discussed about Ethereum, it lets you create smart contracts which are self-executing agreements with predetermined terms. Then you can build decentralized applications, and the native cryptocurrency used for transactions in Ethereum network is ETH. But as any technology has pros and cons. Similarly, Ethereum has trilemma, which means that if you try to focus on any of the two, then the third one would be compromised. So if you try to focus on scalability and security of your application, then you would need to compromise on decentralization. If you focus on scalability and decentralization, then you would need to compromise on security. And if you focus on security and decentralization, then you would need to compromise on scalability. That's where layer 2 solutions comes in. These are the protocols built on top of existing blockchains like Ethereum. They process transactions off-chain, which improves the scalability. They inherit the security from the underlying blockchain, and they are built using techniques like straight channels, rollups, and sidechains. Here are the benefits of L2 solutions. First one is increased scalability, which means faster and cheaper transactions by storing them off-chain. Then second one is lower transaction fees due to the less congestion on the main blockchain. Third one is maintain security. And the last one is it enables faster transaction processing times. Here are some of the major layer 2 scaling solutions like Arbitrum, Optimism, which are built on optimistic rollup solutions, processing transactions off chain. Then there is Polygon, which is sidechain interacting with Ethereum with high transaction throughput. And then there are Starknet and zk which uses zero knowledge proofs for scalability and privacy. If we talk about Arbitrum, it's a layer 2 scaling solution for Ethereum. It utilizes optimistic rollup technology, which offers faster transaction speeds and lower fees, and the development tools are very compatible with Ethereum and smart contracts. Now, as we have wallets in physical world, in blockchain we have digital wallets. It's a tool that allows users to manage their cryptocurrencies and other digital assets like NFTs, non-fungible tokens. There are multiple wallets like MetaMask, Coinbase, Trust, Uniswap, etc. Every wallet has two key components, public key and private key. So if you are from India, you can relate public key and private key with UPI. So as you may know that any UPI app like Google Pay, PhonePe, Paytm, they all have UPI IDs, which are like public keys that you can share with anyone to receive funds from the other person. And in UPI applications, you have your PIN number, which is your private key, which you use to authorize transaction and prove ownership of a blockchain asset, and it should be kept private. Now let's look at an interactive demo. Here we can generate a pair of public key and private key. The private key is used to sign transactions, creating a digital signature that proves identity and intent, much like a physical signature on a paper document, but far more secure. So, if we try to sign any message, let's say hello, with this private key, it will generate one message signature. Now, this message signature and the public key will be used to verify the message. So as you can see, the message is verified. But if I try to change a signature, then you can see the message is not verified. Let's put it all together with a simple transaction. We specify an amount, the senders and receivers public keys, and then digitally sign it with sender's private key. This signed transaction is then broadcasted to the network. The peers verify the signature and the validity of the transaction before adding it to a new block in their respective chains. So, as we saw, transactions are cryptographically signed instructions from accounts. An account initiates a transaction to update the state of the Ethereum network. The simplest transaction is transferring ETH from one account to another. Now, let's look at one of the wallet, which is MetaMask. You can search MetaMask extension. You will see this Chrome Web Store link. You can click on Add to Brave or Chrome, then add the extension. Once the extension is added, you will see this page. You can access your extensions from this button. You can pin the MetaMask. Now, let's create a new wallet using secret recovery phrase method. Here you will be asked to create a new password which will be used to access this wallet. Make sure to store this password because if you lose this password, you won't be able to access your MetaMask wallet. Now, here is your secret recovery phrase which contains 12 phrases that can be used to access your wallet. So, if someone has your secret recovery phrase, then they can use and access your entire wallet. So you should not share this with anyone. You can click on Tap to reveal. You will see these 12 phrases. You can write it down or take a screenshot and it will be used in the next step. where you will be asked to put some of the phrases. The wallet is ready. Here is how the wallet interface looks like. If we try to access it from here, you can see all the popular networks. If you click on this, then you will be able to switch the network. Then, if you click on this 5 network addresses button, you will see the public key for your account, which you can share with anyone to receive any funds. Now, let's look at how you can access your private key. So, you need to click on this hamburger menu, then click on account details, then click on unlock to reveal. Here, you will be asked to put your password, then confirm it. And when you click on this copy button, your private key will be copied, and this is how it looks like. You should not share your private key with anyone, otherwise, they would be able to access all your funds for that account. So, that was all about introduction to Web3 and blockchain. Thank you for watching this video.